Good afternoon and welcome to our first webinar totally dedicated at MillBox Implant Editor. I'm Cristina Fumagalli from CIM System Marketing Team. Today I want to introduce you my colleague Adriano Baschiera, Technical Specialist. Welcome.
Good morning. Here is Adriano Baschiera from CIM System. Today we are going to have a webinar on MillBox Implant Editor and its integration with MillBox. First of all, in MillBox, it's possible to mill directly from STL file or using a replace system feature that is inside MillBox. It's important inside automatic recognition, we can manage directly the STL file if it's a good surfaces. Also because MillBox provides a lot of automatism. For example, it is recognized in an automatic internal interface, like this example we're seeing in the left part of the monitor. In the external interfaces, like this one, and also the recognition of hole dimensions. It can recognize the diameter and the length of each holes. More important is that it's not necessary to have information files from CAD, such as construction info, PTS, HML, etc. It's important to have a quick check before start working on this kind of STL file. So it's important to check that some simple feature was correctly recognized. For example, we can check that all the holes was recognized properly, all the holes was recognized properly, all the connection. Here you can see in different colors, orange and blue. If all this is okay, we can go on. So here you can see some different cases. So external interface, orange interface for internal interfaces. In this case, it doesn't recognize properly all the connection. So this could be a problem working with the normal strategy and directly from the STL file. Here we can see also the red caps for all holes, means that the all holes was recognized properly, not in this image. If all these parts are correct, we can start milling. But replace, we are talking about replace and design a new connection with Implant Editor. The replace mode is a tool that gives to the users the opportunity to remove an interface from the STL and replace it with an interface come from a CAM library. Why I should use this kind of CAM library? For example, because the CAD library is not so good. It's not in of the correct dimension, STL correct dimension. Or in our case, because the STL has a fake interface, so it's not possible to mill properly the STL file. In our case, because I received an STL file from another customer, and I'm not sure about the quality of the interface. So changing the interface with the replace system gives me the ability to have a connection, a proper connection. Or more important, because I can apply different strategy and tools to different types of interfaces. So this, in upside, we can see the original connection from the STL file, that was properly recognized by the software MillBox. And in the image below, we can see yellow colored, the connection replaced automatically with MillBox. So again, we can work directly from STL, but it's better to have the possibility, the ability to change it and use the replace system. Another thing is that I can create my own library of connection. It's important. And there are two different opportunities. I can create my own geometry, drawing my geometry from by myself, or extract a geometry from an STL file. In this case, I should check that the connection, the STL connection, is a good connection. In both cases, I can import this geometry inside the replace library and work with this kind of connection. We are talking about Implant Editor. It's a very useful tool, but we have to take in mind that it is not. It's an add-on of Rhinoceros. So when you buy Implant Editor, you don't buy Rhinoceros license. You have to have Rhinoceros already installed on your computer. Okay, this is very important. Another point, MillBox Implant Editor is a very powerful tools, but is not so, how can I say, to design properly the connection, you have to know different points. You have to know the design, possibly a bidimensional design like this. You have to know the tolerances of the design of the pieces. You have to be able to take this measurement, and so it's very important to understand how they are made and how to measure it. Another point is measurement process are very critical procedures made by extremely precious professional machines. So more and more original pieces are measured, the more we can approach the tolerance on the head office. Okay, so taking in mind this point, Team System developed a software to draw geometries, to draw implant geometries. Its name is MillBox Implant Editor. It's very easy to use. It's very intuitive. For example, here, this is just a Windows example for external connection. So you start from a point 1 and go through point 2, 3, 4, and 5, simply adding basic shape. In this manner, you can realize your own geometry for implant design. Okay, here you have some kind of some example. You can go on. This one is one I think is the most difficult connection to design and also to mill. And take in mind here is very narrow, so it depends a lot of the tools you have in your machines. This one is another one. Also, this one, it depends on the tools, on the boards you have on the machine. This one is similar without the round corner. This one is another example of connection with the cone part. And this one is another one. Today we're going to design some of this one. This is another one. So the practice that we are going to organize today is to see how Chin System software works for implant dental design. We will start by drawing a simple rotational connection, then move on the free example of anti-rotational system of increasing difficulty. So, as I told before, we need rhinoceros already installed on the computer. So we go back here. Okay, this is rhinoceros. To start, after the installation of a dental implant, you have simple to write Mailbox Implant Editor. Right click. And here it is. This is the first Windows we see about Mailbox Implant Editor. In this Windows, we have two different kind of example. As I already told, it is very simple. We start from the first point, normally where the connection starts. Normally it could be a plane, a flat surface, or a cone. And adding a basic feature, we're going to create our connection. It's important that each point is consecutive to the other. 1, 2, 3, 4, and 5. If you look, it creates a segment here. The same for the external connection. We start from the base, and then we add a simple feature to see growing our connection. Okay, that's it. So, for example, we're going to create a Nobel Biocare Brandmark 4.1 rotational. First of all, here, if we click to add, we can add different feature. Base circle, chamfer cylinder, cone cylinder, and other feature we are going to explore now. So we start from base circle. Base circle is the zero position, Z0 position for the connection. In this case, we put 4.1 diameter is the external diameter. We can hit on redraw, and here we have our first feature of the connection. We can add a cone. For example, now, here you can add the head of the cone, let's say 0.35, top diameter cone, 3.34. We can add the dimension of the bottom part diameter, so is 3.15. And if you remember, in this case, we have to go down with a connection. So we have to subtract with this dimension, this cone. And that's it. This is the first part of the connection. Again, we can add a cylinder. Here we can add the value of the height, 0.75. Here the diameter, obviously the diameter needs to be the same of the bottom diameter of a cone upstairs. Otherwise, for example, I put 2.5, that is very too small than the diameter. We have this kind of connection, okay? But if the surface need to be continuous between the cylinder and the cone, they have to add the same diameter. Okay. Now we have to add the hole for the screw. So is a cylinder again. The head is 0.25, sorry. Diameter is 2.07, and again subtraction, redraw. Automatically, the software design a flat surface is the bottom part of the implant and a cylinder. We add now a cone that is the set of the screw. The height is 0.41. Top diameter is the same diameter of the hole, so 2.07. Bottom diameter is 2.7. That is the dimension of the screw head. And redraw. Here it is. Last feature we need to have is the a cylinder for the diameter of the screw head. So we go here in Add, Cylinder, for example, 1 millimeter. It doesn't matter the dimension in this case, the dimension of the last part of the implant. Just a few, so that the MillBox, after we import the connection, can recognize the set of the screw, of the head of the screw, and in this case 2.7. That's it. This is our first connection. It's important we can save this one, and in a second moment we can modify, or better, copy, modify for a different size of connection, and save again. So you can increase day by day your library. So let's say save rotational 1. Okay, yeah. Similar to this connection or rotational connection, now we are going to realize a Nobel-Bucher-Brånemark 4.1 anti-rotational. So we can add a new one. As usual, we start from the base circle. As before is 4.1. We add then a little cylinder, very short cylinder. Diameter is 3.24. And also in this case, we have to reduce. So go down with the Z. Perfect. Now we have to add the hexagon. In this case, hexagon, heptagon, or other polygon, you can select this one. Here, first row, you can select the height of the polygon, 0.75. Number of sides, in this case, for Brånemark is an hexagon. Here you can select the distance from parallel side of the hexagon. In this case, 272. Eventually, you can select also an orientation. To see how we work the orientation, here you can set. Take a look on these surfaces. I changed, let's say, 20 degrees, redraw, and you can see that it rotates. But normally it doesn't need this information. Okay. Second, I had to add a cylinder for the screw hole. So add a cylinder, height of 0.41, diameter is 2.07, and that's it. Automatically, the software made a flat surface and add a cylinder. Now we can add a cone, that is the set of the screw, 0.41 of height. Top diameter is 2.07. Bottom diameter is 2.7. Redraw. That's it. We can add the last feature, the cylinder, 8.1, and diameter 2.7. That's it. Now, one thing that we don't see before. Here I have narrow edge. In this add-on, this software, we can prepare a round corner on the vertical edge. For example, here I go back to polygon. I go a little bit down in edge transition. I select fillet. Here you have two different possibilities, fillet or chamfer. In this case, fillet. And I want to modify only vertical edge. And I put 0.25. Sorry. And redraw. That's it. So it's very, very easy to design. But again, it's very important to understand and to understand which kind of tools you have on the machine. Possible to have bidimensional design of the connection and so on. Okay, we can now design a new case. So I go in, we save this one, save as. Okay, and we are going to design a new connection. In this case, a tri-lobe. So, for example, we add base circle 5. As before, we start always with the base circle. We add a tri-lobe. First one is the height of the tri-lobe, 1.25. The external diameter, 3.94. The inner diameter is 2.9. The lobal diameter is 1.1. And we can, in this case, we add and we draw. So this is 1.1 diameter. This is 2.9. The diameter that touch this, and this point are 3.94. It's important to notice that this kind of sharp edge is no machine can realize. So we have to add a little fillet. So for example, here is 4.95. That's it. We can add a cylinder, 1.5, diameter 2.9. Again, add, and here we have this one. You can add also a chamfer on the top, 0.2, and redraw. It's better. Okay. Now we have to add the cylinder for the screw. So the screw hole. So we add a cylinder. The dimension in this case is 5 millimeter. Diameter 2.2. Here I give a redraw with add. It's wrong, so I have to change and redraw. It's very easy. Last one, the set of a head screw, 1 millimeter and 2.8. Again, subtract, okay. And that's it. This is my new connection. We can save. and replace 5.0. Okay. So it's very easy to design and eventually to modify. For example, now I want to modify the brand mark I already designed. So I go here, open this one. Okay, and now I don't want this type of edge. So I go back here in polygon, go in fillet transition, reset this one, redraw, and save again with a different name. So I can use for a different customer, for example, 4.1 straight. That's it. Okay, so this now we have to go on Mailbox. So we can close this one and go in Sintering in Mailbox. Here, how can I import this kind of a geometry of Mailbox Implant Editor? Simply, I open Mailbox project, empty project. I go on Tools, and I click Import Interface. Automatically, the software go inside here. Sorry for the Implant Editor. Okay, and this one. I go to select my implant. Click OK. And here, I can select. First of all, I have to give a name to this strategy. To this replace. Could be test rep 5.0. I can select the standard strategy or better the custom strategy. So if I click on custom strategy, automatically the software show me some kind of connection. For example, the first group is for external rotational connection. The second one for internal rotational, and so on. Is automatically it's a strategy dedicated to this kind of connection. In this case, the connection is this, similar to this. So I can select exactly this one. Okay. Eventually, I have to select an alignment. Could be this one. With the mouse, I go near an edge, and that's it. This one is my new replace. The position inside the database library is 208. That's okay. Here I can select if I can add to a group. In this case, as could be a replace or another one. Let's say add a new group. Okay, this one is to import a connection in Mailbox. Now we can go on and check how to change the connection. So we open job. Here we change the connection of this kind of implant. So in this case, automatically Mailbox detects properly the connection. But I'm not sure about the dimension of the connection because it came from a different customer, and I don't know which kind of CAD software he used for design, and I don't know the connection. So I select Tools, Replace, here I select which connection I want to replace. In this case, this one is the only one in the project. Click OK. Here the software show me a list of connection I have in my own database. It's not the connection I have in my database, but the type of connection of the abutment. So this one is no replace 5.0. Okay, is this kind of connection. And second phase is to select which connection I want to replace on this. In this case, is this one, the one we have designed with MillBox Implant Editor. Simply click OK, and the software is calculating to take off the original interface and put the new one. Here it is. Yellow colored connection means that MillBox already replaced the connection with the one you designed in MillBox Implant Editor. It's very easy, and that's it. In our case, we can see about replace is this one. I go open a new job. Okay. Obviously, you can replace the connection in for anti-rotational and non-rotational. But in this case, we have a problem. Normally, we can't use an anti-rotational and a rotational one. I know that we can do it, but normally we can't. So in MillBox, you can replace an anti-rotational with a rotational one. I know these two are the same, Brandemark 4.1. So I can go here, replace this. This is an anti-rotational one, okay? As before, here I have to select which kind of connection is on the STL file. Is a 4.1 Brandemark RP. And this one is the connection I want to replace. So the connection I want to insert. Okay. And as we see, automatically detect and draw some curves, axes, etc. Here I replace the same, just an error. I have to replace with a rotational one. Okay, this is a anti-rotational one, and I want to put the rotational. Okay, that's it. Here it is. I can also check and made a comparison between the original one and what I put on. It's exactly on the same plan, so perfect. The same on this side. Replace this one, yeah. In this case, it's a rotational one. Okay. Sorry, here's this one. Okay, and this. Okay. is useful not only in these cases, but give me some minutes and I show you another important cases where a replay system is very important. Another things that in MillBox we can do is extract a geometry. For example, I know that my scan software and my CAD software has a very good library for implant. I can decide that to select the the connection, I use it in my library for milling. In this case, simply I go to this icon, extract connection. I select this one. Okay. I can say here is, I don't know, I give it a name. I give it again, also in this case, I select a strategy, dedicated strategy. Okay. All these strategies are divided by type of connection, not by the name of connection, but kind of connection. Okay. More, I can give a reference curve for the face, and I can add a cylinder for the extraction. Here I can select smaller. Okay. And add a second cylinder for the part of the screw. So I can change the dimension. Okay. That's it. And automatically, the software move this connection to my database folder. In the meanwhile, we open another connection, another project, in which I show you how important is the replace system for dental implant. In this case, we are going to see an implant bridge with two implants, in which the connections are fake, not original. There's no type of connection. You can see now. Look at here. This one isn't a real connection. It's a fake. So we can go and change this one. This means that you are able to properly mill and produce your file. So again, tools, replace. I'm going to select this one. Okay, one of the other is the same. I can add another one. Sorry. This one could be, yes, could be this one. Okay. Here I select the other connection that is equal. I suppose it's equal. It's the same. And the software automatically changes both. And that's it. It's very, very easy and simple. I want to show you another particular connection, probably the most difficult. So we go back, Mailbox, in Rhinoceros and in MillBox Implant Editor. Okay. And we start to design one of the most important, most difficult connection I know. the strum on this. 0.5. Top diameter is 4.8. Bottom diameter is 3.8. And subtract, withdraw. We can add another cone, 0.5. Top diameter is 2.9. Bottom diameter is 3.3. In this case, we have to add, withdraw. Now we add a polygon, 1.2. A side, parallel distance is 2.7. And OK. We need to put a chamfer on the vertical edge, 0.2. Withdraw. OK. We can go add a cone, 0.58. Top diameter is 2.3. Bottom diameter is 2.75. Withdraw. Now we add the cylinder, that is the hole for the screw, 2.6. Diameter is 2.05. In this case, I have to subtract, withdraw. That's it. The screw seat has a conical shape, so 0.2, 2.05, and 2.5. Sorry, 2.5. Withdraw. This one. Last one, the cylinder. 1 millimeter, 2.5 of diameter. And that's it. Now I want to show you one thing. Normally here it's better to have a round shape. Originally is this one, but depend on which kind of tools you have. So for example, in this case, the maximum radius, sorry, is 0.21. So fillet, bottom edge, 0.21, withdraw, and also in the other cone, 0.21, withdraw. As you can see, it's very easy to design, but to draw. But we need to have more and more information about the connection, design and measurement and tolerance, and also about the tools we have on the machine. It's very, very important. Otherwise, the connection we are going to design could be wrong. An important thing about this type of software is that is parametrically, if you want to call it. In the sense, I mean, you can design, you can try to mill. If the friction is too high or too low, you can go back in this design, in this software, change a little bit the dimension that needed, and redesign and remill. The problem is not in the software that design the connection or in the software that calculate the toolpath. This is important to say, because each material, each tools, each machine is different to another one. So it's impossible to design a single connection and working in different machines with different tools, expect to have the same result. It's impossible. And this kind of tools is very useful for this side. Okay. Let's see how, okay, in our case, we can analyze. This one is the strategy, the connection we extract from the STL file. In our case, last one, because I think we almost finished the time, what I want to show you is this one. As you know, Mailbox also have the possibility to use to work with laser melting. The module is make and mill. We can replace the connection also in this case. So for example, this, okay. So the replace system works on the milling machine, but you can organize your work also for make and mill. This kind of work it will be analyzed in a different webinar by my colleague Giorgio. But just to show you, and as we've seen before, we can use many different kind of replace system. Okay. I can replace this one as before with a connection from my database or from a geometry I designed with MillBox Implant Editor. In this case, this one. And that's it. Eventually, here, you can add a particular connection or simply select this one. Another thing from this side of the MillBox Implant Editor that I don't mention before, you can see here you add a second tab, Sintering Protection. So in the first tab, you design your connection. In the second tab, you can design a protection for the sintering. So I can design a protection that made some material more that have to be take off during the milling operation. For example, here I can create a cylinder from the same diameter, so 5 millimeter, or a little bit more, 5.2, 0.2 millimeter height. Okay. Wrong. Here is 0.2 and here 5.2. Withdraw. Okay. Then I can add another cylinder. I don't know. Let's say, have a look here. Each square is 1 millimeter. So you can put, I don't know, we try 1.5, diameter 3. Withdraw. And here we have our connection. I suggest to make a little bit bigger, wider, and bigger in diameter. Withdraw. And that's it. So during the sintering phase, the machine will be going to sinter this type of connection. When you go back in make a mill, you are going to realize the original connection, and that's it. Any question? I think we have completed our.
Okay. For the moment, we have not other question. Just some compliments for your exposure.
Thank you very much. One thing that I can say more, this webinar will be replicated in different languages, in Italian and probably also in Spanish. Let's say connect with our team system and check it for another webinar.
Okay, I think now we can close this webinar. Thank you, Adriano, for your time. And I can remember that the registration of this webinar will be available in the next few days on our YouTube channel, CHIM System Dental. Just a second, maybe we have the last questions.
Yeah.
Okay. I'm sorry, Dimitros, but I don't read any of your question. Could you write again, please? The documentation about MillBox implant export, I think, will be available in our website soon. And in this case, we can give you more material for your documentation.
Yeah, sure.
Okay, I'm sorry, but no, only thank you, Adriano.
Thanks again. Thank you.
Just one more question. I didn't understand the protection for sintering. Can you explain again, please?
Okay, yeah, sure. Okay, when you go to laser melting, let's go back on this one. Okay, when you go on to laser melting this particular, obviously it's not possible to mill, to produce this part, the connection part, with an accurate milling producing accurately. So it's better to produce it with a cap, with this kind of cap, and after the milling, the laser sintering phase, go back on the machine and work by milling only the connection you have. So in the machine, you have to add a particular support. Now I show you just a little bit, but as I already told you, my colleague Giorgio will make a webinar soon on this part.
Okay, we have 4 minutes again for just the 2 questions again.
And that's it. You send this net to the laser melting, then it go back to you, and you can put on your machine with a particular holder and mill only the connection. Did you understand now? Is it more clear?
I can go with the next question for the last 3 minutes. And they ask us is for all machines.
The replace system? You mean the replace system or implant bridge in MillBox Implant Editor?
I think a MillBox Implant Editor, but we can ask to our customer if can be more specific.
Mm-hmm. Because the design, it doesn't for the design, it doesn't matter which kind of machine you have. The only thing is to understand which kind of burst of tools you have on the machine. Understand this, you can design for each machine you want.
Okay, you say the editor will be able to apply the MillBox versions.
It depends on which MillBox version. Yeah, it's a module you can add to MillBox to your version of MillBox.
Okay, so I think we have finished with this webinar. I can give you our big thanks for your time, and
thank you.
See you next webinar. Please follow us on our social media for the next schedules. Goodbye.
Thank you. Goodbye.